Okay guys, trig identities and proofs. So you are doing a little bit of highlighting and then a little bit of like boxing and circling, okay? So the first thing I want you to for sure do on the very left side, go ahead and draw your 777 or your hexagons. So somewhere on this paper, it doesn't have to be right here, but go ahead and draw your hexagon. I did it right here because that's where my Pythagorean identities were. So these are all things that you already know. You know tangent is sine over cosine. You know cosecant is 1 over sine. You know these identities. So we already talked about these identities in the last chapter. Okay? So these are things you already know, but then we're going to keep them in mind for our trig proofs. So you wrote something like that. And then you're going to highlight. To establish an identity, you're going to start on one side of the equation, the harder side. That means that whatever they give you in the beginning, there's going to be an equal sign. You're going to pick the harder side. Go ahead and highlight, underline that harder side. How do you know what the harder side is? It has more stuff in it. So that's one clue. All right, so then you're going to go ahead and, if this was a book question, you would write that down. And then you would rewrite, yes, you have to rewrite. You have to rewrite that harder side. And then you don't get to write anything on the left side ever, ever, ever again. So when you write a proof, you write what you're going to start from, and then you only work on the right side. So what did I do here? I started on the left side, and I go, oh, what can I do? What does that tell me to do? Oh, that means multiply. So then you multiply and you FOIL, and you realize this is a plus b times a minus b. What's a plus b times a minus b? A squared minus b squared. So I FOILed it. And then what is this really? Let me think back to my Pythagorean identities. And cosecant squared theta is right here, equals cotangent squared theta plus 1. So I filled that in. And then minus. And then I get 1. And that's what I wanted. And then I'm happy. Okay, so I always like box it when I'm done. And I put a smiley face. Okay, just because it makes you happy. You know when you smile, it like literally makes you happier. Okay. All right, example 2. So I look at this, and it's kind of hard to tell what the harder side is. I can understand if you think this is the harder side, and you're not wrong, but then I always choose, like if I have a choice between sines and cosines and non-sines and cosines, I choose the non-sines and cosines, because basically I can always turn this into a sine and cosine, and I can probably like mess with it somehow, okay? So you can either start here or you can start here. I'm going to decide to start here. And then, so I rewrite it. So you highlighted it, I rewrite it. And then I rewrite this on the right side. So cosecant is 1 over sine. This is cosine over sine. And then I see, oh, that has sine on the bottom. So then I can just make that into one fraction. How did I get this? Okay, so when you get here, sometimes we get a little bit stuck, and we know we're trying to get this. So what I do a lot of times is I'll be like, you know what? I'm just going to try to multiply so that I get the denominator on top and bottom. So if I multiply by 1, nothing changes. And then I hope that good things happen. So that's what I'm going to do. I'm going to hope. So I multiply by 1. I'm multiplying top and bottom by something that hopefully will help me later. And then when I multiply the top, again, I have that situation where I have a minus b times a plus b, and that gives me a squared minus b squared. On the bottom, I have this. And then on the top, I realize this is just sine squared theta. How did I get this? I used my Pythagorean identity right here. So I solve for cosine. I solve for 1 minus cosine theta, and that would give me sine theta. So then I replace it with sine theta. And then I see, oh, there's 2 of them up here, and there's 1 of them down here. I can divide one of them away, and then I get that left over, and that is what I wanted. From the beginning, I started here, and I'm ending here. I put a box, I put a smile. Yay! Okay, here's what I see sometimes. Are you ready? Sometimes people start here, and then they work, and then they end back here. So they have the same exact thing, and then they box it, and they put a smiley face. Sometimes that's a mistake on your part, and then I'll be like, that's a mistake. And then sometimes that's you trying to trick me. I'm not going to get tricked, okay? So when you start on one side, you're trying to get to the other side. All right, on the back. So I'm going to explain these a little bit faster. So here's my hard side. Obviously, there's more stuff going on. So I write it here. And then I changed all of these to their sines and cosine values. And then I think about this, and I'm like, oh, no, what do I do? Now I have complex fractions. I multiply by LCD over LCD. and then you multiply, and then you can see my work, and then final answer. Okay, so that wasn't a ton of explanation, but I think your friends can help you with that one. Okay, number 4. So again, this side looks harder to some people because there's a fraction, there's a lot going on. But this has cosines and cosines, this one doesn't, so I would start here. So rewrite it. I change it into sine and cosine. I change it into common denominators. And then now it's one fraction because we have common denominators. And then I, from here, might get a little stuck. But I look at this, and I look at my original, and the bottom looks good now. It's the top that's the issue. So the top, I need to somehow get rid of my sine squared. So to get rid of my sine squared, I'm going to go ahead and replace that with 1 minus cosine squared. Again, that's a Pythagorean identity. And then you can see, oh, that gives me negative 2 cosine squared. That's what I wanted to end up with. That's my smiling face. Okay, so again, you start with the harder side. You work exclusively in the right column. Do not write anything else on the left side. Don't set things equal at the end. Like at the end, let's say you're working on this problem over here. Don't put 1 equals 1. No. Just leave it like this. There should be nothing on the left side. Don't put 1 equals 1. That's crazy. You're going to get to IB. You're going to get to like Ms. Knudsen in calc. It drives them crazy, okay, because it's not true. So you don't want that. Okay, and just realize this is making your brain grow. Good luck. Help each other.